Hi everyone, this is my second lecture. I am Dr. T.N. Kavita. In our previous lecture, we have completed the series solution and the definition of ordinary point and the theorem. Series solutions when x equal to 0 is an ordinary point of an equation p naught of d square y by dx square plus p1 dy by dx plus p2 y equal to 0. Its solution should be in the form of y equal to a naught plus a1x plus a2 x square plus etc plus an x power n. This is our theorem 1 actually in the previous lecture, is it? Yes. Now we proceed some problems related to theorem 1. This is the procedure how to do the problems in this type. Series solutions when x equal to 0 is an ordinary point of this equation 1. And this is our first step we have to do. Step 1. In equation 1, p's are polynomials in x and p not equal to 0 at x equal to 0. First we need to check it is an ordinary point or not and substituting x is equal to 0. This is our step 1. Step 2, assume the solution. Let this as equation 2. Step 3, calculate dy by dx, d square y by dx square from equation 2. Step 4, on substituting y dy by dx, d square y by dx square in equation 1 given equation, we can calculate the values of a2, a3, a4 etc. in terms of a0, a1 on equating various powers of x. This is our step 5. And step 6, after finding the a2, a3, a4, we substitute it in our solution equation that is called as equation 2. We get the exact solution or desired solution or required solution. Okay. Within the 6 steps, we easily complete and find the required solution. Okay. So we will go to see the problem 1. This is our example 1. Solve in series. The equation given is equation 1. First we let it the given equation as equation 1 d square y by dx square plus xy equal to 0. Step 1, put x equal to 0 and find it is an ordinary point. Okay. Step 2, assume the solution, that is equation 2. Step 3, find dy by dx and d square y by dx square, that is step 3. Step 4, on substituting y dy by dx, d square y by dx square in given equation 1 and we find this equation. Here in this equation we need to equate the coefficients of various powers of x. First, x power 0, that means the constant term gives a2 equal to 0. Coefficient of x equal to 0 gives you a3 value. Coefficient of x square gives you a4 value. This is already in terms of a0 and a1, so no need to change. Here coefficient of x power 3 equal to 0 we are putting now. We find the value of a5, but this a5 is in terms of a2. But we need to find the a2, a3, a4, a5 values in terms of a0 and a1 only. So replace this a2 by the a2 equal to 0. On substituting a2 equal to 0, the a5 also becomes 0 now. Okay. So in general, we can get the nth term, x power nth term gives the general term of this a3, a4, a5, etc. We find from the general term we find the an plus 2. This is minus an minus 1 divided by n plus 2 n plus 1, which is called as recurrence relation. This relation is called as recurrence relation. On putting n equal to 4, 5, 6, we find the values of a6, a7, a8, a9, etc. So now we find A2, A3, A4, A5, A6, A7, A8 up to 9 we find, right? So you just go and substitute these values in equation 2. That is our solution, required solution. Here wrongly I put equation 1. Sorry. Actually in equation 2 we need to substitute and separate the A0 term and A1 term, means we get the required solution. This is the solution. Okay. Within 6 steps we complete easily. The next example, the similar to it, example 2. Here the equation given is equation 1. Step 1, first we check ordinary point on substituting x equal to 0. Next step, second step, we consider the solution. This is equation 2. Third step, find dy by dx, d square y by dx square. Step 4, in step 4, substitute y dy by dx, d square y by dx square in the given equation, that is called as equation 1. We get this equation. On equating the coefficient of x power 0 gives a2 value in terms of a0. Coefficient of x gives a3 value in terms of a1. Coefficient of x square equal to 0 gives a4 equal to 0. The coefficient of x cube equal to 0 gives a5 in terms of a1. So no problem. General term also we can find easily using the nth coefficient, x power n the coefficient. From that we find a n plus 2, that is n minus 2 by n plus 1 a n, which is called as recurrence relation. On substituting n equal to 4, 5, 6, 7, etc. in a n plus 2, we find the values of a6, a7, a8, a9. Here on substituting these values of a2, a3, a4, a5 in equation 2, that is our solution. So in equation 2 you substituting and separating the terms of a0s and a1s, we can get the required solution. This solution is in series, so we call it as series solution. So within the 6 steps we completed this problem. Again we go for the procedure. Only 6 steps. The first step is we have to check the given equation is of ordinary point or not. So on substituting x equal to 0, we check it is ordinary point. Second step, consider the solution. Third step, calculate dy by dx and d square y by dx square. Step 4, substitute these values of y dy by dx, d square y by dx square in the equation 1 given. And step 5, on equating the coefficients of various powers of x, we find the values of a2, a3, a4, etc. In step 6, on substituting the values of a2, a3, a4 in terms of a0 and a0 and a1 in the equation 2, that is our solution equation, we can find the original solution or desired solution or required solution. So only within 6 steps we can do it. 2 problems we have completed in this lecture. In the type 1, that means the theorem, using the theorem 1. In our next lecture, we are going to see the second type problems. With like this procedure also I want to give you in the next lecture. So in this next lecture, third lecture, we are going to see the series solution when x equal to 0 is a regular singular point. Okay, so we will see in the next lecture. See you, bye. Thank you.